So, good morning, everyone. So, today we have a proposal entitled Unlocking Parking Potential, which aims to minimize traffic congestion in parking lots as well as making it more convenient for owners to park and also to have less time in looking for a parking slot. So, to further discuss this, I will show the pseudocode for this proposal. So here in our pseudocode, we first initialize the things that needed to be initialized, such as the parking area for each categories and the parking area for the total parking lot, as well as the um, car length and width for each category, and as well as the lights that that will uh, specify which category is that specific parking lot, and as well as the total amount of cars that can park in that specific category. So after initializing those things, we will input the car's length as well as its width. After that, we will check if the car length is within less than or equal to 14 feet, or if its width is less than or equal to 6 feet. And if it is yes, then check if there is still an available parking space. And if yes, the car will park and it will display success park in compact area, and which will subtract to the total amount of cars that can park in the compact area. But if there is no available space, then that car will automatically go to step 20, which is to exit the parking area. And if the length and the width ranges from 14 feet to 16 feet, or its width is equal to 6 feet, or 6 feet to 6.5 feet. And if it's yes, check if there's still available space. And if yes, then it will display success, park in standard area, and will subtract to the um, total amount of cars that can park in the standard area. And if it's no, then just the same as before, it will automatically exit the parking area, which will it will go to step 19, which is to check again if its length is equal to 16 feet to 18 feet, or its width is equal to 6.5 feet to 7 feet. And if it is yes, it will again get inside the parking area of large car, and it will check if there is still an available space. And if yes, it will display success park in large area and will subtract to the total amount of cars that can park in the large um, area. And then if it's no, it will proceed to step 20. And if the car doesn't fit within the range of length of 16 feet to 18 feet, or width of 6.5 feet to 7 feet, then it will display vehicle is too large and will automatically proceed to step 20, which is to exit the parking area. And that's it. And to further discuss and to visualize this, I will, Mr. Jan Dominic Garcia will show us the flowchart of this pseudocode.
Okay, thank you, Mr. Mais. So, for the flow chart, let me set up quick. Okay, so to further elaborate and discuss, here is the flow chart. The parking allocation system begins by initializing the parking areas, which is the compact, standard, and large areas with defined dimensions and available slots, in which are 24, 22, and 20 respectively. So when a vehicle arrives, its and width are input into the system to determine its eligibility for a parking spot. If the car fits within the dimensions for a compact area and there are available slots, it parks it parks there, reducing the compact counter by 1. This applies also to the standard and the large areas too. And if a specific area or all areas are full, and if the car exceeds the largest dimensions, the system displays an error as you can see with these on-page connectors, that if a certain area or a certain size is full, it will display that there's an error and that particular area is full, and you need to exit the said parking area. And so, after this, if the cars are what you call this are fit and the parking area is not full, uh, successful parking is confirmed with a display message with the particular area that is parked in, and the process ends. So to maximize the wait, here is the overall picture. And with that said, I'm gonna give the floor to Mr. Juarez to explain and demonstrate our MATLAB code.
Thank you for that flowchart, Mr. Garcia. So now let's move on to our MATLAB code. So our MATLAB code is composed into three parts. First is the initialization process. So in the initialization process, we set up the foundational data for parking space, such as the counters, the parking space length, width, the area, and the specific dimensions for each vehicle. Now for this, step two is the creating the UI figure. In a UI figure, it needs also to display the user interface on what would be the inputted length and width dimension of the car. It would also display how many spaces does it occupy, and what will be its result status when the user inputs its car's length and dimension. Now, for the other part, which is like the second part of this UI, it will show you the parking lot user interface. So we decided to use different colors so that it would be easier to determine what parking size is available. So for the compact car type, it will be visualized in green box. For the standard car type, which is will be the blue box, and the large car type will be in the magenta box. Now for this part, the nested function, it is to check the availability of the said parking space for a certain car. This feature utilizes the smart logic to efficiently allocate the slots while providing an immediate response for the user interaction. Now, let's say if the car is already like parked within a certain area, it would automatically change the color into red of the based on the car's input length and width. And this also corresponds to the different car sizes from compact to standard and to large. Once it already parked on the specific assigned area, it will automatically reduce the counter by one to the said counter of the area, which is stated over here. Once it already sets subtracted the counter to -1, it will change automatically the color of the user interface from, for example, to green to red. And this is just to reiterate the slot type and to determine the counter. Now for the demonstration, this would be the user interface would look like. The user would input its length over here, the width. This is the available spaces for compact, which is labeled in green. The standard will be labeled in color blue, and the large car would be labeled in pink or in magenta. So, for example, Mr. Garcia would like to park his car. However, he needs to input first the length and width so that to check if the area is available or not. So, Mr. Garcia, what will be the length of your car?
For the length, it's 12.4 feet.
12.4 feet. And for the width, and what will that be?
The width is 5.5 feet.
5.5 feet. Once the user inputs its length and width, he will click the check parking. The UI will display success parked in compact area, and based from this UI, The the one in color red signifies that this parking space has been occupied. Now let's say another car would like to park within this establishment. Mr. Mais, could you give me another car dimension?
So my car has a length of 15.3 feet and a width of 6.2.
Six. After inputting its length, it would automatically change the designated parking area, which is the standard based on the dimensions, and the display will say success parked in standard area. Now, let's say I would like to park my car, which is around 17 feet in length and width of 6.6 feet. Now, to check the parking, yes, there is a large area which is accommodated for this type of car. Then the area over here will signify that this area has already been occupied. So as you can see, the user interface works, and this will be displayed before the car or before the car could enter the parking area so that they could maximize the time and efficiency. Now, what would happen if the car length exceeds the limit? Let's say 20 and the car width is around 8. It will display on the user interface no suitable parking area because the vehicle is too large. Since the vehicle is too large, we cannot accommodate any parking area. Hence, the car cannot park within this establishment. So, in the event that the parking area will be left with one and it's already been occupied, when another vehicle would like to pass within this dimension, the length of 18 or width of 7, when I click the check parking, it will display error. The large area is already occupied, it's already full as displayed in color red. This signifies that the car owner could not park within this establishment. It is advised to leave immediately so that he could save time and look for another parking area space. So this would be the user interface would look like if all the parking spots had been occupied by the compact size cars, the standard size cars, and the large cars. Now, what would happen if another car would like to park within this area? When the user or the car owner would input its dimension, let's say 12, and the width is 5, and would like to check parking, it will display the compact area is full. This would advise the car owner to look for another parking spot to save time and not go around within the parking establishment looking for something that has already been occupied by other vehicles. So that concludes our computer programming project proposal.